Let f be the function, this piecewise function that's given up here, and we want to know what are all values of a and b, which are constants here and here, for which f is differentiable at x equals 1. Notice that x equals 1 is where this piecewise function splits right here, or it possibly splits. A couple of things we know about just the way this question is worded. It says if f is differentiable at x equals 1, well, that means that f has to be continuous. And if it's differentiable, can't spell continuous, so f is continuous. And if f is differentiable at x equals 1, then that also means that f prime exists when x equals 1. So we're going to use these two pieces of information to solve this problem. Let's first talk about the continuity of f, and the definition of continuity says that if f is continuous at x equals 1, then the limit as x approaches 1 from the left, which would be on this piece right here, because x is less than or equal to 1, we're on this piece right here. So we'll put x plus b is equal to the limit as x approaches 1 from the right, and from the right of 1 means x is greater than 1, so we're going to be on this piece, ax squared, and the part that makes it continuous is that that's equal to f at 1. Well, f at 1 and the limit as x approaches 1 from the left are the same value, so we're just going to pick out those two, and you know that because the equal sign is on the inequality is on the top piece right there. So the way you evaluate a limit is by substitution, if that will work. So we're going to let x actually be 1 right here, and we get 1 plus b equals, same thing, let x be 1, so we get a times 1 squared, which is just a. And that gives us this relationship between a and b. Now let's look at the f prime exists when x is equal to 1. First thing we need to do is take a picture of f prime, and it's going to be piecewise as well. If I'm on the top piece and I take the derivative with respect to x, then I'm going to get a 1 where the x is, and b is a constant, and so the derivative of that is going to be 0. So f prime is equal to 1 when x is less than or equal to 1. And then if I go to the next piece, remember a is a constant, so I'm just going to take the derivative of this x squared, bring the 2 down in front, and I get 2a times x to the 1 less power, which would be to the first, and that's the derivative when x is greater than 1. The only way that the derivative is defined at x equals 1 is if this piecewise function is continuous. So I'm going to do the same thing on the derivative that I did right there. I'm going to look at the limit as x approaches 1 from the left of the top piece, and I want to know that that's equal to the limit as x approaches 1 from the right, which would be the bottom piece. And for continuity, that has to equal f prime at 1. But again, f prime at 1 and the limit as x approaches 1 from the left is going to be the same thing because of the equal sign. So if I evaluate this limit, the limit of a constant is just the constant, and I evaluate this limit by substituting in the 1, and I get 2 times a times 1, or 2a. So now I have this relationship for a, and I have this relationship for a and b. If I solve this for a, then I get a is equal to 1/2. And then if I use that value of a right here, then I get 1 plus b is equal to 1/2. Subtract 1 from both sides, and b is equal to negative 1/2. Look back at your answer choices. We're looking for a is 1/2, b is negative 1/2, and that corresponds to the first answer. So a is your answer.